All of you welcome in our third period of mathematics, paper 2, set theory and Laplace transform. Myself, Dr. D. N. Varane. In the previous period, we have seen this example. Find the Laplace of cos h to the power 40. In this example, there is Laplace of cos h 2t and cos h 4t. Both are hyperbolic functions. We know that the formula for hyperbolic function is a divided by s square minus a square. Here in the first, a equal to, therefore s divided by s square minus 4. In the second, a equal to 4, therefore we have s divided by s square minus 16. Therefore there is s divided by s square minus 16. Therefore here is also s divided by 8 into s square minus 16, which is the required Laplace transform of cos h to the power 4t. Now we see one important theorem which is called as shifting property. First shifting property of Laplace transformation. First shifting property of Laplace transform, which is we write in the form of theorem. If Laplace transform of f of t equal to f of s, then Laplace of e to the power at f of t equal to f of s minus a. That is, if we multiply the function by e to the power at, then Laplace of that function f of s, in this way of s is replaced by s minus a. S is replaced by s minus a. Therefore, the shifting theorem tells us that if we multiply the function by e to the power at, then in the Laplace transform, s is replaced by s minus a. Then we see the proof of the theorem. We use the definition of Laplace transformation. By definition of Laplace transform, we have Laplace of f of t equal to integration 0 to infinity e to the power minus st f of t dt. But we are given that Laplace of f of t equal to f of s, but it is given that Laplace of f of t equal to f of s. Therefore, equation 1 becomes f of s equal to integration 0 to infinity e to the power minus st f of t dt. Now, if we replace here s by s minus a, then we have put equal to s into s minus a, s equal to s minus a in this equation 2 in both sides. Therefore, we have Laplace f of s minus a equal to integration 0 to infinity e to the power minus s minus a into f of t dt. Now, from the equation 1, we multiply both sides by e to the power at from equation 1, multiplying both sides by e to the power 80, therefore Laplace of e to the power 80 f of t equal to integration 0 to infinity e to the power minus st e to the power 80 f of t dt. Then here addition of indices e to the power minus st into e to the power 80, we have e to the power minus st plus 80, therefore integration 0 to infinity e to the power minus est plus 80 f of t dt. Then we can write here integration 0 to infinity e to the power minus, we take minus n common and t is common, therefore minus of s minus a into t f of t dt. Laplace of e to the power 80 f of t now from the definition or by equation 2, the right hand side is nothing but f of s minus a by definition of Laplace transform. Therefore we have this as f of s minus a. Hence we put the property Laplace of e to the power 80 f of t equal to f of s minus a. That is, if I multiply the function f of t by e to the power 80, then in the Laplace of f of t, that is f of s, in the Laplace of f of s, s is replaced by s minus a. We will see examples on this property. First example, find Laplace of e to the power 4t t cube. Laplace of e to the power 4t t cube. Now here it is in the form of Laplace of e to the power 80 f of t. You compare the both. Here f of t we get this e to the power 80 means e to the power 40, and f of t means we have t to the power 3. Therefore we consider f of t equal to t cube. Solution. Let f of t equal to t cube. Then we take Laplace. Therefore Laplace of f of t equal to Laplace of t cube. We know that Laplace of t to the power n is given by the formula factorial n divided by s to the power n plus 1. Here we have n equal to 3. Therefore we have 3 factorial divided by s to the power 3 plus 1. 3 factorial, that is 6. 6 divided by s to the power 4, which is the Laplace of f of t, that is Laplace of t cube. 6 divided by s to the power 4. Then we use the shifting theorem or shifting property by using shifting property, or you can say by using the shifting theorem. Laplace of e to the power 80 f of t equal to f of s minus a. Now here e to the power 80 means e to the power 40. Therefore S is replaced by S minus A, that is S is replaced by S minus 4. Therefore, to find the Laplace of given function, we replace S by S minus A in equation 1, that is we replace S by S minus 4 in equation 1. Hence, we get Laplace of e to the power 4t, t to the power 3 equal to 6 divided by S minus 4 to the power 4, which is the required Laplace transform of the function Laplace of e to the power 4t t cube. And we see the second example. Find Laplace of e to the power 18 sin bt. We know that Laplace of sin bt equal to b divided by s square plus b square. Then we use the shifting theorem. Therefore, by using shifting theorem, we have s is replaced by s minus a, here e to the power 18, therefore a equal to a. Therefore, Laplace of e to the power 18 sin bt equal to b divided by s minus a whole square plus b square, using the shifting theorem. Therefore, Laplace of e to the power 80 sin bt equal to b divided by s minus a whole square plus b square. By using this shifting property, we write some formulae. First, if my f of t equal to sin 80, then Laplace of e to the power bt sin bt. First we write Laplace of f of t, Laplace of sin 80 equal to a divided by s square plus a square. Now multiply by e to the power bt, then by our shifting theorem, here the value of a is b, therefore we have a divided by s minus b whole square plus a square. Then second, Laplace of cos 80. You know Laplace of cos 80, s divided by s square plus a square. Therefore, if you multiply the function by e to the power bt cos of 80, then by shifting theorem, s is replaced by s minus a. Here a is the, here a means b, e to the power 80 means b, a equal to b, therefore s minus b divided by s minus b whole square plus a square. Third, we know that Laplace of t to the power n, that is n factorial divided by s to the power n plus 1. Therefore, Laplace of e to the power 80 t to the power n equal to n factorial divided by s is replaced by s minus a to the power n plus 1, s minus a to the power n plus 1. Then next, you know Laplace of sin 80, it is given by a divided by s square minus a square. Therefore, Laplace of e to the power 80 sin 80 equal to a divided by s minus b whole square minus a square, replacing s by s minus b. Therefore, Laplace of e to the power bt sin at equal to a divided by s minus a whole square minus a square. Then find Laplace of cos at. The formula for Laplace of cos at, you know, s divided by s square minus a square. Therefore, if we multiply the function by e to the power bt, Laplace of e to the power bt sin at equal to s is replaced by s minus a. Here s is replaced by s minus b. Therefore, s minus b divided by s minus b whole square minus a square. These are some formulae by using the shifting theorem. Then we solve some examples of finding the Laplace transform by using this shifting property. Example: find Laplace of e to the power minus 3t into 2 cos phi t minus 3 sin phi t. Solution. Here we use the shifting property. Therefore, we have Laplace of e to the power at into f of t dt. F of t. Here we have f of t equal to this function. We consider, let f of t equal to 2 cos phi t minus 3 sin phi t. Then we take Laplace on both sides. Therefore, Laplace of f of t equal to Laplace of 2 cos phi t minus 3 sin phi t. Take the Laplace of cos phi t 2. We know Laplace of cos at s divided by s square plus a square, a equal to 5. Therefore, s divided by s square plus 5 square, that is 25, minus 3 Laplace of sin phi t. We know that Laplace of sin at a divided by s square plus a square. Here a equal to 5. Therefore, 5 divided by s square plus 5 square, that is 25. Therefore, we have this as the LCM is s square plus 25. In the numerator, we have twice s minus 15. Which is the Laplace of f of t. F of t means this, which is denoted by f of s. Then we use the shifting theorem to find the Laplace of e to the power minus 3 into this. Therefore, by using shifting properties, we have Laplace of this function. Now here s equal to a equal to minus 3. Therefore, according to shifting theorem, s is replaced by s minus a. That is, s is replaced by s minus a equal to minus 3. Therefore, s plus 3. Therefore, we have the Laplace of this as, we replace s by s minus a in the equation 1. This is f of s. By shifting formula, we have f of s, it gives f of s minus a. Therefore, replacing s by s minus a in the equation 1. Therefore, Laplace of this is given by 2 times s minus 3 minus 50 divided by s minus, if there is minus then we have plus here, therefore s plus 3 square plus 25. Then simplifying this, 2s plus 6 minus 15 divided by s plus 3 whole square plus 25. Therefore, twice s minus 9 divided by s plus 3 whole square plus 25. You can simplify the denominator, s plus 3 whole square, s square plus 6s plus 9. Therefore, we get this as twice s minus 9 divided by s square plus 6s plus 9 plus 25. Therefore, we have this as 25 plus 9, 34. Therefore, Laplace of this function into the power minus 3t into 2 cos 5t minus 3 sin 5t is given by this twice s minus 9 divided by s square plus 6x plus 34. Then we see the next example. Laplace of e to the power t. Find Laplace of e to the power t into t square plus 1 square of this. Now here it is in the form of Laplace of e to the power 18 f of t according to shifting theorem. Therefore, we have e to the power 80, that is e to the power t, a equal to 1, and f of t we consider t square plus 1 square. Therefore, let f of t equal to t square plus 1 square. When squaring this, we have t to the power 4 plus 2t square plus 1. Then we take Laplace on both sides. Therefore, Laplace of f of t equal to Laplace of right hand side. Then by linearity property we separate the Laplace of each term. Therefore, we get Laplace of e to the power 4 plus 2 into Laplace of t square plus Laplace of 1. You know the formula for Laplace of t to the power n. What is the formula? N factorial divided by s to the power n plus 1. Here we have n equal to 4. Therefore, 4 factorial divided by s to the power 4 plus 1, that is 5, plus 2 into Laplace of t square, here n equal to 2 factorial divided by s to the power 2 plus 1, 3. Laplace of 1, you know, it is 1 by s. Therefore, we denote this by now 4 factorial, we have 1 into 2 into 3 into 4, we have 24. Therefore, 24 divided by s to the power 5 plus 2 factorial means 2, 4 divided by s cube, plus 1 by s. Now Laplace of f of t, we denote by f of s, therefore this is f of s. F of t means this function t square plus 1 square, therefore Laplace of t square plus 1 square is given by this, which is denoted by f of s. Then by shifting theorem, by using shifting property, we find Laplace of e to the power t square plus 1 square. Now here e to the power at f of t equal to this, and e to the power at means e to the power t, therefore we have here value of a equal to 1. Therefore according to shifting theorem, s is replaced by s minus a, that is s is replaced by s minus 1 because a equal to 1. Therefore we put s equal to s minus 1 in the equation 1. Hence by shifting theorem we have Laplace of e to the power t square plus 1 square equal to, put s equal to s minus 1 in equation 1, therefore 24 divided by s minus 1 to the power 5 plus 4 divided by s minus 1 cube plus 1 divided by s minus 1, which is the required Laplace transform of this function. Now stop here and try to solve some example from the book. Thank you.